Have you ever noticed how even the smartest AI can ace a test, but then fail at the simplest common sense question? This is the common sense bottleneck, the gap between raw intelligence and real understanding. Let's start with the black box. Modern AI, especially deep neural networks, are incredible at pattern recognition. They can spot a cat in a photo, translate languages, even write essays. This is what psychologists call System 1 thinking: fast, intuitive, and automatic. But here's the catch. These systems don't really know why they make the decisions they do. Ask a neural network to explain its reasoning, and you'll get a wall of numbers, not a clear answer. That's the lack of explainability. And when it comes to common sense, basic facts about the world that humans take for granted, these models often stumble. They can memorize data, but they don't truly understand context or causality. That's the bottleneck. Now, let's talk about the logical bridge. This is where neurosymbolic AI, or NSAI, comes in. Imagine combining the strengths of neural networks, pattern recognition, with the clarity of symbolic reasoning. Neural components handle perception, like recognizing objects or parsing language. Symbolic components use rules and logic to reason about those perceptions. For example, if a neural network sees a red ball on a table, the symbolic system can infer, if the ball is pushed, it will roll off the table. This bridge allows AI to audit its own reasoning, trace its steps, and explain its decisions in human terms. It's like giving AI both intuition and logic, and letting them work together. But integrating these two minds isn't easy. The benefits are huge: explainability, robustness to new situations, and data efficiency. AI that can learn from fewer examples, just like humans. But there are real challenges. The semantic gap is one. Translating messy, high-dimensional neural data into crisp, symbolic concepts isn't straightforward. The bridging problem is another. How do you connect the fluid, statistical world of neural nets with the rigid, rule-based world of symbols? And then there's the cost. Combining these systems can require massive compute power. So, where does that leave us? Neurosymbolic AI promises a future where machines don't just predict, they understand, explain, and reason. But the path forward is still full of open questions. Bridging intuition and logic in machines may be the key to true artificial intelligence, but it's a puzzle we're still learning how to solve.